I would like my students to understand that the process involves vaporizing the liquid, then condensing the vapor back to a liquid and collecting it.
You'll be using distillation extensively to remove solvent. It's a good idea to know the setup. It's quite complicated. So let's go to the stagehands to show us how to do it step by step.
The boiling point of a liquid is defined as the temperature at which the vapor pressure of a liquid equals atmospheric pressure. The vapor pressure can be thought of as the amount of compound in the air at a given time, and it varies with temperature. Pure liquids that are stable when heated have well-defined boiling points, but boiling points are dependent on atmospheric pressure. The higher the atmospheric pressure, the higher the boiling point. The reverse is also true. Have you ever tried to boil eggs while hiking in the mountains? It takes a little longer, since the water is boiling at less than 100 degrees because the atmospheric pressure is lower. When you actually distill a liquid and measure the temperature of the vapor gradually increases until it reaches the boiling point of the liquid. When the vapor and liquid are at equilibrium, the temperature will remain constant until the distillation is finished. To set up your distillation, start from the bottom, and this means choosing a heat source. The choice of the heat source is influenced by both the flammability and boiling point of the liquid. A steam bath should always be used for low-boiling, flammable liquids, those boiling less than 85 degrees Celsius. For higher boiling liquids, heating mantles or, using great care, Bunsen burners may be used. In this demonstration, we have chosen a Bunsen burner because water has a high boiling point, 100 degrees Celsius. The Bunsen burner has two controls, a needle valve on the bottom and an air inlet located as a collar at the bottom of the barrel. The needle valve is used to regulate gas flow, while the air inlet adds oxygen from the air. To use a Bunsen burner, get your match or ignition source ready, then close the air inlet completely. Turn on the gas tap at the bench and light the burner while opening the needle valve about a quarter turn. This should produce a pale blue or orange-yellow flame of about 15 centimeters high. Start opening the air inlet by twisting the bottom collar of the barrel. Do not touch the top, it is hot. Adjust the air until a double blue flame results as shown. To shut off the burner, close the gas tap on the bench. Let us complete the assembly of the distillation apparatus. You will need an iron ring and heat-resistant gauze to place below your flask. The gauze is used to spread the heat and prevent cracking your flask. This is placed about 10 centimeters above the Bunsen burner. Clamp a round bottom flask above the gauze and ring. Choose a flask of an appropriate size for the volume of liquid to be distilled. It should be about half full at the start of the distillation. In this example, we will be distilling about 50 milliliters of solution, so we are using a 100 milliliter round bottom flask. Add some boiling stones, then pour the liquid in using a funnel. Grease the lower joint of the still head three-way adapter. Greasing helps to prevent so-called freezing or sticking of the joints. Place this joint in the neck of the round bottom flask, thereby building a distillation flask. Lightly grease the inside of the thermometer adapter. Then position the thermometer bulb at the upper edge of the adapter side arm. When done this way, the thermometer bulb will be properly moistened by the vapors and give a true boiling point reading. The distillate is collected in the receiving flask. Loosely clamp the receiving flask and place it approximately where it belongs. Lightly grease the condenser and insert it in the vacuum adapter. Align the condenser with the joint on the sidearm of the distillation flask and complete the assembly by inserting the vacuum adapter into the neck of the receiving round-bottom flask. Clamp your condenser using the metal joint clamps. Note the location of all clamps. A common tendency of beginning students is to over-clamp apparatus. Too many technical clamps can stress the glassware, causing it to break. Avoid placing undue pressure on the glassware. Tighten the clamps only enough to hold each piece in place. You are now ready to distill, but first ask yourself, have I made a bomb? Never heat a closed system. It may explode or fly apart. Have a look at the vacuum adapter sidearm. If it has an opening to allow pressure to equalize, then the question has been answered. This is not a sealed system and not a bomb. Start your distillation by adjusting the water flow through the condenser to a modest flow rate. No benefit is gained from a fast flow, as the increased pressure in the apparatus may cause a piece of rubber tubing to pop off and cause an unexpected bath. It is good practice to clamp the hoses to the condenser and to the water faucet. Apply heat at such a rate that the liquid begins to boil gently and the reflux ring of condensing vapor rises slowly into the still head. Shortly after the reflux ring reaches the thermometer, the temperature reading should rise sharply as vapors begin passing through the sidearm into the condenser, coalescing into droplets that run into the receiving flask. As the first few droplets come over, the thermometer reading should rise to an equilibrium value. Record the value at which the temperature stabilizes and check the thermometer reading frequently throughout the distillation. Distill the liquid at a rate of about 1 to 3 drops per second. Collect the distillate until the upper end of the expected boiling range is reached, or until only a small volume of liquid remains in the boiling flask. Remove the heat source and transfer the distillate to another container. Disassemble and clean the apparatus as soon as possible after the distillation is completed. Let us review the steps to assemble the apparatus and carry out the distillation of a liquid.